Hello everyone and welcome again to another science video lesson, and the topic of our video lesson for this session is the characteristic of the image formed in a plane mirror. Yes, you guessed it right. So that is plane mirrors or flat mirror. So come join me in this video lesson as we discuss and find out what is the characteristic or what are the characteristics of the images formed in a plane mirror. Alright, so here we are on our lesson about plane mirror. So in this lesson, we will going to discuss also the image form in the plane mirror and also with the reflection in a plane mirror. Okay, so there will be a demonstration about the ray diagram, about the reflection in a plane mirror. So please watch that one out later. Alright, so today we will going to find out what is a plane mirror, images formed in a plane mirror, reflection in a mirror, and also some sort of multiple images. How is this one possible using a plane mirror? Alright, so what is a plane mirror? Plane mirror is a very familiar object. Alright, you can see this object in the bathroom, in your makeup kit, okay, for girls. Alright, also we can see this one inside the elevator. The walls of the elevator, most of them are contains a mirror inside, or some of the malls, okay, that you went through. All right, it contains a lot of mirrors. All right, so some of them contains a lot of mirrors, or even in a entertainment park. All right, so multiple mirrors or mirror room, something like that. Okay, so that is a plane mirror. So the one that they are using there is a plane mirror, or simply called as a flat mirror. Alright, so what are the images formed in the plane mirror in the first place? So the mirror or the plane mirror follows the parameters of the law of reflection. Okay, it follows the parameter of the law of reflection, which states that the light or the angle of incidence, alright, is equal to the angle of reflection. Okay, when light reflects. Okay, so this is the law of reflection. So basically, all things about how the image is formed in the mirror is governed by this parameter, which is the law of reflection. Okay, so upon looking at the mirror, as you can see in the previous video lesson that we had discussed last time, all right, about the reflection, refraction, and virtual images. Alright, as you can see, the reason why inside your plane mirror is the images that is formed in the plane mirror is a virtual image, because none of the reflected rays that you see here, are intersecting in the front of the mirror. Okay, our eyes is being tricked. Our eyes and brain trick us that the reflected rays are being formed behind the mirror. Okay, so as you can see, the intersected rays that you have right here on the intersected reflected rays that you have happens behind the mirror, but there's no such thing as behind the mirror. Alright, there's no such thing as behind the mirror. So meaning to say that this image over here is a complete illusion created by our brain and the eye itself. Alright, so this is a virtual image, to be exact. Okay, that is the image formed by the plane mirror. And also, okay, whatever shape, all right, whatever shape and size of our object, okay, whatever shape and size of our object will be the same thing as the image that are formed in the plane mirror. Okay, so the height of the object is also the same. Okay, and also all the features that are found on certain object, all the features that are found on an object will be seen also on the mirror. Okay, so that is when you look at the mirror. So except for one thing, when you raise your right hand to the mirror, when you raise your right hand in front of the mirror, the image that you have on the mirror will raise its left hand. Okay, the image on the mirror will raise its left hand. So it is laterally reversed. Okay, it is laterally reversed. So that's the reason why the ambulance, written on an ambulance, okay, the ambulance, the word ambulance written on an ambulance is written in reverse. So that is why a person or the side mirror, okay, in front of this ambulance will be seen or will be able to see the word ambulance in a correct orientation. Okay? So in the side mirror of a certain vehicle in front of this ambulance, it will be read as in a correct orientation. Alright, so the image form in your plane mirror is laterally reversed. Okay, laterally reversed. When you raise your left hand, your image will raise its right hand. Okay, so that is laterally reversed. Now, how about image distance? Alright, so how about image distance? So as you can see on this picture, that the image distance is also the same with the object distance. Okay, so no matter how far the object is placed in front of the plane mirror, it is the same with the image. So the one that you have right here. Okay, so the dot that I have right here in front of a flat mirror that I have right here, if you count the number of blocks, okay, supposedly we have 1, 2, 3, 4, 5, 6, 7, 8. So in front of the mirror, there are 8 blocks before this dot that we have right here. Now let's take a look. Okay, let's take a look if really the image distance is equal to the object's distance in the plane mirror. Okay, so let's count. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 blocks as well. Okay, before you reach the dotted part of this graphing paper that I have right here. So really, that object distance is equal to the image distance in the plane mirror. Alright. Alright, so let's have the ray diagrams from the ray diagrams on a plane mirror. So, the purpose of ray diagram is to find out what kind of image and what characteristics of image that we can form on a plane mirror. Alright, so ray diagrams consist of rays. Okay, these rays will represent the light rays. And we will be able, with the use of this ray, we will be able to see how the light interacts, okay, in a certain way, whether it is a mirror or even lenses, okay? So that is the ray diagram. Okay, so we have right here the step-by-step process on how to draw a ray diagram. Okay, so the first step is to identify the top and the bottom of the object. Okay, so supposedly you put some point here, point A, which is the top, and point B, which is the bottom part of the object. Okay, so which is facing. So this is behind the mirror. Alright, so this is behind the mirror. So this is the plane mirror that we have. So the object is placed in front of the plane mirror. Okay, so first draw a perpendicular line. Okay, so you can draw a perpendicular line on the object, on the top of the object to the mirror. Okay, so always follow the law of reflection. If this one is a straight line, if the incident ray is a straight line, alright, so if that is the incident. Okay, so if this one is the incident ray, okay, if this one is the incident ray, so therefore this is the reflected ray. Alright, so why is it that the reflected ray has the same orientation with the incident? Remember, the angle of reflection or the angle of incidence is equal to the angle of reflection. That is what the law of reflection says. So if the orientation of the incident ray is just like this, the orientation of the reflected ray is just like that. Okay? So but it is in opposite direction. So that is why the reflected ray is going away from the mirror, because that is the one that is bounced off the mirror. The incident ray is going towards the mirror. It's because that is the one that strikes the mirror. Or you can even put something here like an arrow directly on the incident ray that you have, just to indicate that there is a reflected ray on it. Alright, so you can put an arrowhead there. Okay, that indicates that this arrow is your reflected ray. Okay, next one. Now, you can also draw, alright, aside from drawing illustrating a perpendicular line, the one that you have right here, over here, earlier, you can also draw a diagonal line. Okay, now the problem with diagonal line, make sure that you check the angle, alright, make sure that you check the angle with respect to the normal line, the one that you have right here, with respect to the normal line, so that you will be able to still follow the law of reflection. Okay, remember, law of reflection says that incident ray is equal to the angle of reflection. Alright, so the one that we have right here. Incident ray is equal to angle of reflection. Okay, so the same thing. You just draw a diagonal line, then measure the angle. Alright, so measure the angle that you have right here. So, for example, hypothetically, I can have here an angle of 20 degrees, for example. Alright, so the angle, okay, this is the incident ray. Alright, so this is the incident ray. So, supposedly, the angle of reflection should be also 20 degrees. Alright, on the other side. So, it will look like this. So, there's your arrow that indicates that it is a reflected ray. Alright, so that is the reflected ray. So, there you go. So, it still follows the law of reflection. Okay, so either of which, so guys, either of which you can put on the top of your object. Okay, so either of the following. Okay, next one. Now, okay, what happened here is we extend the reflected ray. Okay, we extend the reflected ray that we have. Okay, by drawing or by illustrating some, by putting some broken lines behind the mirror. Alright, so these broken lines that you have right here, alright, is the extension of the reflected ray behind the mirror. Okay, so also this blue part over here, so this blue broken lines over here is the extension of the reflected ray. Okay, now when those two broken lines meet behind the mirror, when those broken lines meet behind the mirror, this is where your top part of the mirror is formed. Or top part of the image, rather. Sorry for that. Top part of the image is formed. Okay, so this is the top part of the image. Okay, again, you can draw something like this. Alright, so you can draw something like this, or you can draw something like this to point out where this particular image of the top of the object will form behind the mirror. Alright, so similarly, you can work also with the one at the bottom with the same procedure that we have earlier. Okay, so we have here a line perpendicular to the mirror, and we have here the reflected ray. We have here the incident ray over here. Then we have the reflected ray being continued on the side behind the mirror. Okay, also we have your diagonal line over here. Now, if this is 30 degrees, this should be also 30 degrees with respect to the normal line. Okay, now as you can see, you have your reflected ray over here, and we have your incident ray over here. Okay, so we have your incident ray, and the broken line that you see here is the continuation of the reflected ray behind the mirror. Alright, so that is the continuation. So therefore, when these two broken lines meet on the side, on this side of the mirror, it will showcase the image of the bottom part of the image. Okay, it will showcase the bottom part of the image. Okay, so again, this is the step 5. Alright, so this is the step 5 in which you can do also the same thing, the one that you did on the top with regard to the bottom. Okay, so that is the step 5 on the ray diagram. Now, the step 6, actually there's no step 6 here, I just added it. Okay, so the step 6 is you identify the lost. Alright, so what do we mean by lost? Okay, so what do you mean by lost? So I will just I think put it right here. Okay, so lost. So L means location. So lost is talking about the image. Alright, so lost means the image itself. Okay, location of the image. Alright, so this is about image. Image. Alright, so location, orientation. Alright, so orientation. So what do you mean by orientation? Upright, upside down. Okay, erect or upside down. Next one, size. Alright, so this is the size of the object. Enlarge. Okay, enlarge or magnified. Okay, or same size. Or diminished. Okay, diminished. Okay, next one is the T. Okay, T is the type of image. Alright, that is the type of image. There are two types of image, virtual and real. Okay, again, if you watch the video lesson, the previous video lesson that we had about reflection, refraction, and virtual image is always upright. Okay, real image is always upside down. Okay, so that is the type of image that we have. Okay, so let's analyze what is the location of the image. The location of the image in this example that we have right here is behind the mirror. Alright, behind the mirror. Okay, but in reality, there's no such thing as behind the mirror. We just represent it. Okay, to make things simpler. All right, next one. What is the orientation? So as you can see, the object is not upside down. Okay, the object is not upside down, so this is erect or upright. Next one. What is the size of the object? Did you see some distortion with regards to the size of the object? Did you see some changes? Okay, happened on the object as we put it in the plane mirror. Okay, so there's none. So, same size. And finally, since that is upright, alright, that is upright, there's no such thing as upright real image. So therefore, the type of image that is formed is virtual image. Alright, so again, location of the object is behind the mirror. Orientation of the object is upright. Size of the object, same size. Type of image, virtual. Alright, so that is the characteristic of the object formed in the, or characteristics of the image formed in the plane mirror. Alright. Okay, let's try this one. Okay, let's try this one. Okay, you can have this one. Okay, so you can have this one here using a tree. Okay, a tree that we have right here, which is placed in front of plane mirror. Alright, so you can pause this one and you can do this one on your graphing paper if you want to. So, pardon me guys, pardon me for doing this one because I don't have a ruler. Alright, but in your ray diagram, it should be straight. Okay, for you to avoid confusion. Okay, your ray diagram, all the lines there that you have on your ray diagram should be straight so that you will avoid confusion in forming the images on, or the image on the other side of the mirror. Okay, so let's have a quick look about this tree that we have right here. Again, I don't have any ruler at this point while using the PowerPoint, so please bear with me, okay, with regards to the line that I will draw. Okay, first one is the incident ray. Alright, so first one is the incident ray over here. It will go to the mirror. Right, so it will go to the mirror and it will be reflected back. Okay, so I can put some arrowhead here to symbolize that that is the reflected ray. Alright, so this is the reflected and this is the incidence. Okay, so I can continue that incident ray, or I can continue that reflected ray behind the mirror. Okay, when you have your ruler, you can measure. Okay, you can measure this line. If you have a ruler, you can measure this line, and that's the amount of line, or that's the amount of length, or the length that you will have on the other side. Okay, okay. Since I don't have a ruler, so I will draw the second line, which is the diagonal line. Okay, so the diagonal line, I can put it right here. I can put it on top. Okay, I can put it on top. I can put it on the bottom. All right, or on the same part. Okay, so let's have this one since we don't have the extension of the plane mirror on the other side. So we can put it right here. So as you can see, we have here the incident ray. Alright, so this is your incident. Okay, next one. Following the angle or following the law of reflection, it should be, again, I don't have any protractor at all. So I will just assume. Alright, so I will just assume that it goes this way. Okay, so the light goes this way. So this will be your reflected ray. Alright, so this is the normal line. Alright, so that is the normal line. So this is the angle. So we can continue the reflected ray on behind the mirror. There you go. So that is the top part of your object. Alright, so that is the top part of your object. Okay, so there you have it. Now I change color to blue. Okay. Now again, from the bottom part of the image, from the for the bottom part of the image, I can use the same thing. So I can draw a line there that indicates the incident ray. Right, so that is the incident ray, and I can put a arrowhead that indicates the reflected ray. Okay, so I can continue the line there on the other side using a broken line. Okay, guys, again, I repeat, this broken line is the continuation of reflected rays. Okay, so these broken lines that you have right here is the continuation of the reflected rays. Alright, next one. Let's draw a diagonal line. Alright, so let's go draw a diagonal line over here. It goes right there. Okay, so that is the incident. Okay, and let's assume that the line, since I don't have a protractor, let's assume that this line goes somewhere here. Okay, so again, this is the normal line. This is the angle. Okay, so we will continue the reflected ray. So this is the incident ray. And this is the reflected ray. So we will continue the reflected ray on the other side. So again, pardon me if I have a distorted line that I have because I don't have any ruler that can be used here in PowerPoint. Alright, so with that, we have now the bottom part. Alright, so we have now the bottom part of the object. Now, we can draw now the object on the other side. Okay, we can now draw the object on the other side. So, it looks like this. Alright, so it looks like this and that. Alright. Okay. So, that is the object or that is the image of the object. And what is the loss? Okay, so what is the loss for this one? Okay, so what is the loss? Okay, location of the object or location of the image rather. Location of the image is behind the mirror. Behind the mirror. Okay, next one, orientation. What is the orientation of the object? Orientation is upright. Alright, next one, or erect. Okay, you can have that one. The size of the object, as you can see, same size. And the type of image that is formed, virtual or real. So as you can see, if it is upright, therefore automatically that will become a virtual image. Alright, so that is the loss for this image that we have right here. Okay, so let's have some simulations. Okay, let's have some simulations about this plane mirror. Okay, to better understand the images formed by your plane mirror. Okay, so we have here your eyes. Okay, we have here the eye. And if we put some image in front of the plane mirror, okay, in front of the plane mirror, okay, so this is what the eyes or this is what the brain sees. Okay, this is what the brain interprets. Okay, in a plane mirror. Okay, so as you can see here, okay, so as you can see here, the object being placed in front of the plane mirror has the same size with the image that you have right here. Okay, so another one is right, so another one right here is the whale, or let's have the orangutan. Alright, so if we try to use protractor regarding the angle that we have right here, we can safely say that, alright, so we can safely say that the angle that you have for this certain one is 16. Alright, so we can have it 16 on this side. And if you put a protractor on the other side as well, okay, so if you put a protractor on the other side, this is hard. This is harder than I thought, huh? Okay, so also we have okay, so it doesn't straight up. Okay, so we have also 16. Okay, so we have also 16 if we follow the second line that we have right here, so the second line that you have. Okay, so really that angle of incidence is equal to the angle of reflection rather. Okay, so if we can use other images like the one that you have right here, crocodile, so it will be the same thing. Okay, so it will be the same thing, guys. Okay, so that is the images formed in the plane mirror. So again, let's have another example. Okay, so what about an object which is placed in the front of a flat mirror, and we have an eye now. Okay, so how can you solve this problem, or how can you draw a ray diagram in this problem? Okay, so again, you can pause the video, okay, if you want to, okay, to practice yourself in a graphing paper, okay, and practice yourself working on a ray diagram in a plane mirror. All right, so what we have right here is a ball pen, okay, this is a ball pen. And first thing that we will going to draw is a line that is perpendicular. Okay, I want to draw a line that is perpendicular to the surface of the mirror. Okay, so from the top of the mirror, so this is the top, this is the bottom. So I will draw an incident ray. All right, and also on that incident ray, I can draw a reflected ray. So this is the reflected ray, this is the incident ray. Alright, so we can continue that line, or we can continue that reflected ray on the other side. Okay, so there you go. Okay, so how about the eye? Okay, so how about the eye? Now, I can have a diagonal line here, which serves as the incident ray. Alright, which serves as the incident ray, and as much as possible, I will try my best to make it go to the eye. Okay, so let's assume that we follow. Alright, so this is the reflected ray. Okay, alright, so that is the reflected rays. Okay, so if you follow the law of reflection, this the angle that you have right here should be similar. Okay, the angle of incidence should be similar to the angle of refraction. Okay, so what we have right here is let's have the continuation of the reflected ray. Okay, so that is the continuation of the reflected ray. Okay, or okay, let's do it once again. Okay. Okay, so the first one is line perpendicular to the flat mirror. Okay, and also the reflected ray over here, reflected. This is incident. Okay, so there you go. Okay, so next one, now if you put the diagonal line downward, so it will be harder. Okay, it will be harder for the eyes to see the reflected rays continued on the other side. So we can use the top part. Okay, we can use the top part of this. We can use the top portion, and this will be your incident ray. And it goes now to your eyes the way it goes right here. Okay, so if you follow the law of reflection, alright, if you follow the law of reflection, it should be the same angle. Okay, so the rays will continue. Okay, on this part. Again, pardon me, I don't have any ruler. Okay, for this one, so it's hard to draw a line without a ruler. Alright, so you can have your graphing paper. So that's the advantage of having using a graphing paper. Okay, for this one. Okay, so we have now the top part of the object. Okay, next one. The trickiest part here is the bottom part. So how will you send a light ray to the eye in the bottom part? So first one is, let's draw first the perpendicular line. Okay, again, we can have it like this. Okay, so again, the dotted lines that I am illustrating here, comes from the reflected ray. Okay, it comes from the reflected ray. Next one. So how can we reach the eye? Alright, so we can have it diagonally. I will use another color for this one. Okay, so I can use blue. Okay, so let's put a diagonal, an incident ray diagonal over here. So I will just make sure that it will go to the eyes. Okay, so this is the incident ray. Okay, and if you follow the law of reflection, okay, so that is the normal line. So the angle here should be equal to the angle of the reflection. Alright, so there you have it. Okay, so we have it angle of reflection. Okay, so let's continue the reflected ray. Let's continue the reflected ray. And we have it over here. Alright, so we have it right here. And we can now draw the ball pen. Alright, so we can now draw the ball pen that you have right there. Or rather, we have it right here. Okay, so also the orientation of the... Also, we can follow the orientation if it is slanted. Okay, so the object or the image also will be slanted. So since I have drawn already, okay, so this will be the ball pen. Alright, on the other side. Okay, the same size. Okay, so assume that this will be slanted. Alright, okay, the way it was positioned, okay, in front of the plane mirror. Okay, so that is the ray diagram. Lost. Okay, let's have the lost. Location of the object behind the mirror. Orientation upright. Alright, so orientation upright. Size of the object, same size. And we have the type of image, which is virtual. Alright, now let's go now to the last part of this topic, which is multiple images. Okay, now if you place two plane mirrors, okay, if you place two plane mirrors in front of the... Okay, if you place two plane mirror in front of an object, okay, at a certain angle, it will create multiple images. Okay, the one that you have right here. Okay, now I have another one, which is right here. We have how many images? 1, 2, 3, 4, 5. Okay, so I think we have 1, 2, 3, 4, 5, 6, 7. Okay, so that is the number of images. Okay, if you place the flat mirror in front of the object the way it was right here. Okay, there's also another one. Okay, so how is this possible? Okay, so how is this possible? At a certain angle, there are certain images that are formed in your plane mirror. Okay, so it follows the formula. It follows the formula of n. It follows the formula of n, which is the number of images, is equal to 360 divided by the angle, theta, minus 1. Alright, for example, I have, what is the number of image? Alright, what is the number of image formed when you have 360 and you arrange the flat mirror to 120? Alright, so you arrange the flat mirror into 120 degrees, okay, to each other. So, minus 1, what will be the number of image? So, we have it 360 over 120 minus 1. So, that will be 2. Okay, so this is 2. Okay, meaning to say, if you have two as your number of image, all right. So if you have 2 as number of image, it means that, okay, so it means that your flat mirror is arranged as 120 degrees to each other. Okay, so the one that you have right here, this is 120 degrees. Okay, so how about this one? Okay, so how about this one? So probably this one is N is 360. Alright, so probably this is arranged as 40 degrees. Alright, so that's my assumption. Minus 1. So 360 over 14. So we have 9. Alright, so 9. Then minus 1, that will become 8. Alright, so 8. So 1, 2, 3, 4, 5, 6, 7. So we have extra. So this is not 40. Okay, it means that this is not 40. So we can have another one. We have 360 degrees divided by, so if 40 degrees, okay, 40 degrees arrangement will produce 8 number of images. Alright, 8 total number of images. So we can have 360 divided by 60. Alright, so we can have 60. Then minus 1. So what will happen here? So that will be 6 minus 1. That will be 5. So again, at certain degrees or at 60 degrees. Okay, at 60 degrees arrangement, we can produce total number of 5 images. Okay, so let's have another one. Let's try to find out this one. So if 40 and 60, okay, if 40 and 60 failed to do that one, so we can have, I think, 30. Okay, 360 divided by 30. Okay, so 30 is too much. Alright, next one, how about 50? Alright, so 50 is 7.2. Minus 1, it's still 6. Alright, so it's still 6. So we have 50. How about 55? Okay, so 55. Alright, so that will be 7. That will be 6 as well. Alright. 65. Okay, so how about 35? That will be 10. 45. Okay, so 45. So N is equal to 360 degrees over 45 degrees minus 1. So N is equal to 360 over 45. That will become 8 minus 1. 8 minus 1 will be 7. So this is in a 45 degree orientation. Alright, so the mirror is 45 degrees over here. Okay, so that's how you compute the number of images. And the last one is the infinite images. So the infinite images, or this is also known as infinity mirror. Okay, so as you can see here, the images are created from 1 point to infinity. Alright, so how is this possible? Now, when you have two flat mirror and arrange them parallel to each other, so meaning to say that there is another flat mirror in front of this mirror. So this is the first mirror, and the second mirror is in front of this first mirror. So they are now in parallel to each other. Alright, so they are now parallel to each other. So this is your mirror. Okay, so they are parallel to each other. Therefore, the number of images is infinite. Alright, so the number of images that you will form is infinite. So placing the mirror parallel to each other will create infinite number of images. Alright, so with that, let's have a summary of everything that we have discussed on this video lesson. Okay, so number 1 is the image formed. Okay, so the image formed in the plane mirror is virtual. Okay, it is behind the mirror. Okay, so next is the image is laterally reversed, which means that if you raise your right hand in the front of the mirror, the image on the mirror will raise its left hand. All right, next one, the image in plane mirror is erect and or upright. Okay? Next one, the image size. Alright, the image size that is formed in the plane mirror is the same as the object size. And finally, the distance. Alright, so the distance. The image distance is equal to the position of the object in front of the mirror. Okay? So these are the characteristics formed, or the characteristics of the image formed by the plane mirror. Alright, so with that, alright, so we end up again another video lesson. So I hope you did learn something about all about the plane mirror and all about the ray diagram. So if you do have question about this lesson that we have right here, you can write down something in the comment section of the video. Now, if you learned something from this video lesson, just hit the like button, okay, below, and also subscribe to my channel and hit the notification button for you to be updated with a lot of science video lesson in the future. Alright, so with that, I hope you did learn something from this video lesson, and let's see each other next time to another science video lesson. Peace out, everyone. Take care.
バカみたい子供なのね夢を追って傷ついて嘘が下手なくせ